do really well. Okay, so we're going to be getting into our rationals unit. This is one of the most important units of the year. This is one of the most important units to know and understand for calculus, which you will all go on to. You're all in here because you're calculus bound. If not, you're not even in the right class, but you are. You guys are our prestigious students. You're going to go on to calculus. So, you will see this stuff again next year. It's really important to know this stuff. So, the first lesson is 2-1. We're going to learn 2-1 and 2-2 today. Both very straightforward lessons as long as you can factor, which I think we're all pretty good at factoring in here. The first thing we're learning is how to simplify rational expressions. Now, rational means fractions. We're going to be dealing with rational expressions. So, an expression means like it has a variable. It's just an expression here. We're not solving. It's not an equation. It's just x plus 1 over x plus 2. It's an expression. It's a rational because it's fractions. So the first thing we're doing is learning how to simplify them. Now I'm making a point here. 10 over 6, this is how we simplify. This is how we simplify other rationals that are harder as well. These are the steps we take. Factor the top. 5 times 2. Factor the bottom. 3 times 2. Then you'll divide out exact factors. So doesn't 2 and 2 divide out? So my answer would be 5/3. That's literally the steps we take when simplifying all rational expressions. Now we do have to note one thing though. When we start putting variables in with rationals, we have to recall that we cannot divide by 0. Now this would restrict the values that we could potentially plug into this. We're restricting our input or our domain. There are values we could not plug into this or else it would make it undefined. If you look at x plus 1 over x plus 2, what value would make the denominator 0? 2. So we say x minus 2, since that's in the denominator, cannot equal 0. True? It's a true statement. Now add 2. So x cannot equal 2, or the denominator is 0, making this undefined. So that is one thing we always have to write in, is what's called a restriction. We have a domain restriction. So if I asked you, this is just writing the domain restriction, then if I ask you what's the domain, you'd say all real numbers, I can plug anything into this, except I just can't plug in 2. But that's the only value I can't plug in. Do you agree? We don't need to have a restriction on top, we can have a 0 on top. Does everybody kind of understand where I'm going with that? Yeah. Okay, awesome. Okay, now one thing to know, when simplifying, we can only divide out exact factors. This is really important. We never divide across an addition sign or a subtraction sign. Yes, okay. We never divide across addition or subtraction. So everybody look right here. This would not be okay with x plus 2 over x plus 4. First of all, just curious, what would my domain restriction be? X cannot be what? -4. Good, -4. Now I can never divide across an addition sign. X plus 2 is connected with an addition sign. You cannot divide out x's like this. That's dividing across an addition sign. Do you see what I mean by that? You can't say 2 and 4 divide out. That becomes 1 over 2. You just divide it across an addition sign. It can't happen. That is really bad. So literally that did not simplify, guys. X plus 2 over x plus 4 did not simplify. Nothing could divide out. We can divide across multiplication signs, however. So everybody look. We have an x plus 1 on top here. We have an x plus 1 on bottom. Now, this is a multiplication sign right here, right? As long as we can divide out the whole factor, we're good. Does everybody see the difference? So you can divide it out if the whole thing is there. If you're dividing out an entire factor. Now, first of all, we would restrict. So my restrictions here would be the denominator can't be 0, so x can't be? -1. Yep. Good. And now we can divide out exact factors. That and that divide out. So left on top was a 1, and then on bottom, x minus 2 is left. Now, we always restrict before we divide. That is important. So we got to restrict first. Because what we're really doing is we're saying, if we have this original problem right here, if I plug in any value, like let's plug in a 0, it will simplify to be this, if you plug in 0. So this is the answer, the simplified answer. So could I plug in a -1? No, because then it would make the denominator 0, right, everybody? So would it simplify to be this? No, it would simplify to be, it wouldn't simplify, it'd be undefined. Does everybody see? Okay, awesome. Okay, let's look at this one. We can divide across multiplication, but not division. My restriction here is x cannot equal 0. Now, a lot of times I always have people wanting to put in -4, which is natural to kind of fill at first. But just remember, you'd say 4x cannot be 0. Now divide by 4, so x can't be 0. So just don't confuse that by thinking you'd plug in a -4. Because if you did, you'd have negative 16, which would be fine in the denominator. Okay, now let's divide out exact factors. 3 and 4, nothing divides out, but x squared and x, doesn't that divide out to be x on top? So then my answer would be 3x over 4. As long as x does not equal 0, because if it did, it wouldn't simplify to be 3x over 4. It would be undefined at 0. Okay, now question for you. Let's test your abilities and your knowledge. Could I'd restrict, totally can restrict here, x cannot equal what? 0. Can I divide those x's out? No, because there's a plus sign, right? We can't divide across an addition sign. That would be really bad, so we would not do that. Does everybody see the difference? Okay, right here, looking at this, we have a time sign right here, and so we would restrict first. X cannot be 0. We don't need to list it out twice. And then can't we divide these out?
Yes.
Yeah, because it's just a multiplication sign. So this would divide out to become a 1. This would divide out and become an x. So that would be our answer. X minus 2 over x, as long as x does not equal 0. Pretty straightforward stuff. Okay, here are the steps we take to simplify rationals. First, factor the top, factor the bottom. We factor the top, factor the bottom. Restrict first, that is way important, and then divide. So what happens is people get to the test, they don't restrict first, and then on every single problem on the entire test, they get a half a point or 1 point knocked off. Do you see how those can add up quickly? If you misunderstand one little thing, like I said, the whole test can be a bad news things. Like your score can be bad news. So you got to remember every little thing here. Factor the top, factor the bottom, restrict first, and then divide out exact factors. So let's do our first example here. So it says simplify and then state the domain. So how do we do this? You have to know the steps in your head. Factor the top, factor the bottom, restrict, then divide. So if we factor the top, you'd say, what kind of factoring am I dealing with? A quadratic. So it multiplies to be a times c and adds up to be b. 3 times 2, correct?
Yes.
Okay, awesome. Now check, can I quick factor the top?
Yes.
So I factor it to be p plus 3 and p plus 2?
Yes.
Awesome. Now let's do the bottom. What multiplies to be a times c? What multiplies to be negative 4 and adds up to be 0? 2
and 2. One's going to be negative.
Good. Now we can quick factor the denominator, so I have a p plus 2 and p minus 2. Now we restrict first, then we divide. So my restrictions are p cannot equal.
2 and negative 2.
Good. Negative 2 and 2. You're right. And now we'll divide out exact factors. P plus 2 and p plus 2 divide out, don't they?
Yeah.
So left on top would be a p plus 3. Left on bottom would be?
A p plus.
Good, p minus 2. So that would be our answer. Now our domain, we always state the restrictions within the answer. If I asked you the domain, you would say the domain is all real numbers. I can plug anything in. I just can't plug in negative 2 or 2. So in my answer, I state the restrictions, and then my domain, I would need to say it's any number except negative 2 and 2. So in simplifying, part of the answer is stating the restrictions, really. Okay, let's do another one. It says simplify and state the domain. So let's see. Factor the top, check. Factor the bottom, check. Those are factored. Restrict first. X cannot equal.
Negative 6.
And then divide out exact factors. Can I divide those out?
No.
Nope. So nothing divides out. We would never divide across addition and subtraction. So that's our answer. And then our domain would have been all real numbers except x just can't be negative 6. Pretty straightforward stuff. Okay, let's look up here. What multiplies to be negative 9 adds up to be 0.
Positive 3 or negative 3.
Good. So the top factors to be z minus 3, z plus 3. If we can't factor, we can't pass this test. We've got to be really good at that. Then looking at the bottom, what multiplies to be negative 28 and adds up to be 3. And I can quick factor the bottom as well. So the bottom factor to be z plus 7, and then z minus 4. Now we restrict first. Z cannot equal negative 7 or 4, right? Now divide out exact factors. None. So we would leave our answer. Now I always have people say, should I put it back in standard form? Well, standard form and factored form are equally good. So you could, but why do extra work? Factored is just as good, so leave it. Because what if you made a mistake multiplying it back together? So not one form is better than the other. Okay, so my domain, I would say all real numbers except negative 7 and 4. Okay, I think we kind of get the picture here. So I just want to do one with a little bit more advanced factoring. Guess what? I had on the first test, like 40% of people in this class did not know how to factor two perfect cubes. So let's remember how, because you've got to know this, for, especially in calculus. In your first quiz within the first week of next year, your calculus teacher is going to ask you to factor q cubed minus 8. Two perfect cubes, I promise. Because she came in here to my class and said, why can't some of your students factor two perfect cubes? And I'm like, I have taught that and we went over it 10 million times, so that's not on me. So everybody, here we go. How do we factor two perfect cubes? You cube root the front thing, you get? Cube root the back thing, we get? 2. Then remember the little trick. Q and 2. Then don't we do the front times the front?
Yeah.
Then the front times the back. Then the back times the back. Then what's the sign rule? This sign and this sign are the same. The next sign is opposite. The last sign is plus. Good. Now remember, within two perfect cubes, the quadratic will not factor, everyone. Now, we could try though. It multiplies to be 4 and adds up to be 2. Nothing. So you could try, it won't work. But if you remember that, it kind of saves you some thinking. Can anyone remind me of, can anyone remind me of why maybe this doesn't have, that this doesn't factor more? Where is it definitely going to cross the x-axis?
Positive 2.
Good, positive 2. Now it looks like this. Something like that. I'm just drawing a rough sketch. If it looked like that, it doesn't look like that actually because it shifted down 8, isn't it?
Yeah.
Good, it doesn't have turning points. You're right on. So it looks something like this, crossing at 2. Well, how many solutions does it have?
1, 3.
3. So 2 must be imaginary. Does that make sense? Which would need the quadratic formula. And we're not dealing with imaginaries, guys. We are not dealing with imaginaries in this unit. Okay. Oh, I didn't even, I swear, did I miss something? Let's look backwards. I remember talking about imaginaries at this point in my last lesson. Where was it? Must be coming up in the future. Okay. All right. We were right here. Okay, we just factor the top. Now factor the bottom. What would we pull out in common? That's always what we look for when factoring. Is the greatest common factor. What would we pull out? 3Q. Pull out a 3Q. Then left is Q minus 2. Restrict first, then divide. So Q cannot equal?
0.
Good.
Or positive 2.
Or positive 2. Awesome. Now let's divide out exact factors.
Q plus 2.
Awesome. So then on top we have a Q squared plus 2Q plus 4. And then on bottom we have a 3Q. That's what it simplifies to be as long as Q is not 0 or 2. Because if it was, it would not simplify to be that. It would be undefined. So our domain is all real numbers except 0 and 2. Right, everyone? Okay. Pretty straightforward, right? You can factor, you can do it. Okay, there's a reason I'm showing you this one. And this is where we talked about the imaginaries in the denominator. So on top, we factor out a p. Left is p plus 3. On bottom, you'd say two perfect cubes, p and 3. Then you do your little trick that we've learned, your p and 3. Front times the front, p squared. Front times the back, 3p. Back times the back is 9. This would be a plus sign, this would be a minus sign, this would be a plus sign. Is everybody okay? Now let's restrict. So you'd say p cannot equal negative 3. Now if you tried to factor that, it wouldn't work. And we would need the quadratic formula to solve. And we've talked about how two perfect cubes only have one real solution. Two imaginary. We're not going to have imaginaries. We're going to be, rationals are all in the XY chart, all in the real number line. So we're only ever going to plug in real numbers. So if the only thing that makes this 0 are imaginary numbers, or solving it would be imaginary, there are no restrictions on it. So we're not going to plug in imaginary. We only plug in real numbers. Does everybody see? So you'd say, if I solve this, it would be imaginary. We don't restrict imaginary, so literally we can plug in any real number. So there's no restriction there. So my only restriction is negative 3, and now we can divide out exact factors. So p over p squared minus 3p plus 9. So if you ever have in the denominator something that would need the quadratic formula and it has imaginaries, there would be no restrictions. We won't have imaginaries. Okay, I think we get the picture here. I just wanted to show you, this isn't supposed to be cubed, it's squared. I just wanted to show you this one just for a quick second. On bottom, this is not considered standard form. It's not considered factored, in fact. People will look at that and say it's factored. Well, it's not factored unless it's in standard form. So we would rewrite that as negative 3w plus 2. Now, is it considered factored to have a negative in front? No? Right? So factor out the denominator. What would you pull out? Negative 1, and then left would be 3w minus 2, wouldn't it? Now in top, we get back to the top. I'm just showing you the denominator here. So you would have a negative 1. Would that have a restriction? No. Negative 1 equals 0. Does it equal 0? No, so that's not a problem. What would our restriction be? W cannot equal 2/3. You said it equal to 0. Add 2, divide by 3, right, everyone? And then we would have whatever the top factors to be. We've restricted them. We divide. Are we good? Write things in standard form, and if there's a negative in front, factor it out. I don't need to keep going. I feel like it's just repetitive at this point. Okay, awesome. So, this is my last question that I'm going to let you work on 2-1. If I said to you, what's the domain? I'm not asking you to simplify. I said, what's the domain? What would you say?
X cannot equal negative 0, negative 4, negative 2.
Does everyone agree?
All real numbers.
Good. All real numbers except those real numbers. Does everybody agree? Yeah. That's how, I don't need you to write it any fancier than that. That's how you can write it. Are we all okay? Okay, sweet. So go to 2-1, and you're going to do evens or odds, not both. Evens or odds. So that's just that front page. 2-1 is just that front page, evens or odds. Notice the answers are all off to the side. So if you're not getting a correct answer and you're not understanding where they're getting it, raise your hand and ask. One last thing to note. Notice when it says simplify and their answers on the side, they're not putting the restrictions in. We do need to do that on the test. I'm always going to say simplify and state the restrictions. So when you do your answer, if you get x minus 1 over x plus 2, make sure you also, even though when you check on the side, make sure you're practicing listing out whatever the restrictions were. Does that make sense, everyone? So like your answer really should look more like that. Does that kind of make sense? Because look at their answers, they're not putting in restrictions. You need to, so that you are all practiced up for the test. Awesome. Okay. Alright, so now we're going to be taking and multiplying and dividing rational expressions. Now what you just learned was how to simplify. Simplify is the last step to all of the problems. So, we learned to simplify so we can literally do the last step of all these bigger problems. So in multiplying fractions, remember we can multiply straight across. We don't need a common denominator, we literally just multiply straight across. So I'm trying to show you something, I'm making a point here. If we multiply straight across, the first way we could do it is actually multiply it out. 6 times 10 is 60, right? Yeah. And then we have divided by 15, which is 4. Now that's one way of doing it. That would be technically the quote-unquote harder way. Let me show you the quote-unquote easier way. Multiply straight across. No, actually, sorry. Factor all the parts. So really, don't we have 6 is 3 times 2? Then on bottom I have a 5, that's factored, and then times 5 times 2. And then on bottom I have a 3. Now what we would do is we'd multiply straight across, but not actually multiply it out. So on top I have 3 times 2 times 5 times 2. And on bottom, I have 5 times 3. Do you guys see? So now divide out exact factors. 5 divide out, 3's divide out, and left is 2 times 2 on top, which is a 4. This way is technically easier, quote unquote, because we're not dealing with such big factors. Now, obviously, with something like a number, it's pretty easy either way. But I'm trying to make a point here. When we get to something that is not just numbers, it would be easier to leave it all factored than to have some huge thing and have to refactor it. Does that kind of make sense? Factor it and then multiply straight across, but don't actually multiply it out. Because then what would we do? Refactor it, and wouldn't you end up right back there? So why multiply it together to then refactor it? Do you guys see what I'm saying? Okay. So, here are the steps to multiply rational expressions. Take a picture or write as fast as possible. Okay, so every time you do one of these problems, you guys, I need you to say these steps in your head so that you're not the person that gets to the test and fails it. So the first step is, and if you follow these steps, every problem is easy. This type of problem is easy. So first, we factor all the parts. It says take this rational times this rational. You factor all the parts within the rational. The numerator and denominator, I factor. Now look at my example up there. Do you see how I've taken and just factored all the parts? Okay, second step is to multiply straight across. But do not, I repeat, do not actually multiply it out. That's the step people forget, and then they get to the test, and then on top, they get these huge polynomials that they can't factor, and then they are just completely in trouble. They don't know where to go. So and once again, multiply straight across, but do not actually multiply it out. Leave it factored. Then we're literally to our third step, which is restrict, and then our fourth step is divide out exact factors. So it's actually really easy. Do you see how I multiplied all that stuff straight across, but I didn't actually multiply it out?
Yeah.
Everything on top was on top still. Everything on bottom was on bottom still. I've reordered some of it to make it pretty. So I have an x and an x and x. I have x plus 2, x plus 1. Do you guys see? 4x I put in front. It's just considered prettier. Then I had an x plus 1. I had an x plus 2. I restrict, so I said x can't be 0. X can't be negative 1, and x can't be negative 2. Then I divide out exact factors. So I divided out my x. I divided out x plus 1, and I divided out x plus 2. So I got x over 4. Does everybody see how easy this really is?
Yeah.
Okay, awesome. Honestly, this lesson's easy. But it's when you learn the next lesson that you confuse the steps, then we're in trouble, so you can't confuse them. Okay, so just watch, because you guys get it, then you'll get a practice. I think we know how to factor from here. So the first step in multiplying fractions is to factor all the parts. So factor this. What multiplies to be negative 15 and adds up to be 2? 2. Okay, good. 5 and negative 3. I can quick factor. I'm going to have a place where I put my final factors. So I have x plus 5 and x minus 3. Then I'm going to cross it out. I factored that. That is factored. It has 2 terms. I like to use parentheses around 2 terms. You should too. Then we have times by. Factor that. What would I pull out? Then left is x plus 7. Now on bottom, what multiplies to be negative 21 and adds up to be 4? 7 and 3, negative 3. True? So I have an x plus 7 and an x minus 3. I've done step 1. Now the second step is to multiply straight across, but don't actually multiply. I put x's in front because it's prettier. So I have x, I have an x plus 5, I have an x minus 3 on top, and then I also have an x plus 7 on top. Then on bottom, I have an x plus 1, I have an x plus 7, and then an x minus 3. I'm promising you guys, if you were to multiply all that out, you're going to have something that's so big, and then you're going to be stuck. Because you're not going to know how to factor. Does that make sense? Okay, restrict first. X cannot equal negative 1, negative 7, or 3. And then divide out exact factors. Is that it?
Yeah.
Perfect. So then x plus 5 was left on top, and then on bottom x plus 1. Yes, you could distribute. Not necessary, though. Super easy stuff. Okay, so. Yeah, exactly. So everyone, you say, okay, I'm going to multiply factor all the parts. When multiplying, I factor all the parts. When multiply to be negative 9 and adds up to be 0. So I have a p plus 3 and a p minus 3. Moving on. Factor that. What multiplies to be 6 and adds up to be 5. And 1 and 6, but then that one wouldn't work because it would need to be negative, right?
Yeah.
So that does quick factor to be p plus 3 and p plus 2.
Yeah.
And I factor that bad boy, which is going to be long factoring, so I'm going to have some work down here. So we have what multiplies to be negative 6 and adds up to be negative 1. 3 times 2, negative 3. Negative 3 plus 2. Check, check. Long factor. Drop and break. So I drop down 3p squared. I drop down negative 2. Breaking down the middle term as these two factors. Minus 3p plus 2p. Factoring by grouping. Pulling out the greatest common factor, 3p. Left is p minus 1. Pulling out a positive 2. Left is p minus 1. Pulling out p minus 1. And then left is 3p plus 2. Agreed? Okay, now I have times by p minus 1, 3p plus 2. Then on bottom, I'm going to pull out a greatest common factor 2, and then left is p minus 3. Now, we've done step 1. Now our next step is to multiply straight across, but don't actually multiply, correct? I don't have anywhere to write it. Honestly though, do I even need to rewrite it? Couldn't I just go like this? Well, if I need to multiply straight across, couldn't I just go like this, extend my line?
Yeah.
Isn't that just a multiplication sign? So pretend you're scooting it. Then I do like to write 2 in front because it's prettier. Just remember that's multiplication right here. Multiplication, multiplication. You guys see what I did? Okay, restrict. Right here, p cannot equal Negative 3.
2 or positive 3.
Okay, good. And then divide out exact factors. P plus 3.
P minus 3.
P minus 3.
That's it.
So left on top was P minus 1.
3P plus 2.
3P plus 2. And then left on bottom. 2P plus 2. Pretty straightforward stuff, guys. Awesome. Okay, then I think we're good with multiplication. Do you agree?
Yeah.
How would you factor this bad boy, though? Yes, you would have to put it in standard form, and then you'd have to take out a negative 1, so that actually factored to be that. Just don't forget that, or else you're going to be in trouble. Okay, awesome. Now let's go on to division. This is literally going to take us 2 seconds, and then we're going to be done, but you got to focus.
Okay.
Dividing fractions is easy as pie. Flip the second fraction and multiply. So let me say that again. Dividing fractions is easy as pie. You just flip the second fraction and you multiply. Cute little saying, right? Dividing fractions is easy as pie. Flip the second fraction and multiply. So don't we already know how to do that?
Yep.
So look, dividing fractions, ding ding, is easy as pie. Flip the second fraction, that would be this one. And multiply. Oh, well, we already know how to do that. Are we all good at that?
Yeah.
Now here is one thing. With division, make note. In your notes, put a little thing. Division, and huge thing, like make a note somewhere.
Okay.
With division, there is going to be an extra restriction, and I'm going to explain why right now. So we know with multiplication, we restrict denominators. So if this would have had an x and an x plus 1, we only restrict here and here, right? We restrict our denominators, right?
Yeah.
That's still true, but there's an extra restriction with division. Now let's talk about why. Case number 1. If we have some a divided by b divided by c and d, let's pretend like b is 0. A divided by 0. Can we divide by 0?
No.
No, so we have to restrict right there. B can't be 0. You can't divide by 0, right? So there would need to be a restriction right there. Moving on, case number 2. Let's say we have some a divided by some b divided by 0 divided by d. Now everyone, wait a minute. 0 can be on top, correct?
Yes.
So 0 divided by d is fine. That becomes 0. Now we have a problem because now it's divide by 0. Do you guys see?
Oh,
So this can't be 0 only because it will make this 0, which would then make divide by 0. Does everybody see? So we have to restrict there as well. Now case number 3. A divided by b divided by c divided by 0. Uh-oh, we can't divide by 0. So also d cannot equal 0. So with division, not only do we have to restrict the denominator, we have to restrict every piece except for the very top corner. So in this one, the one that we wouldn't restrict would be the 2. We restrict everything else, every other piece, which is different than multiplication, right? Okay. So let's just look at an example. You'll see what I'm saying. So everybody, you say, okay, dividing fractions is easy as pie. We flip the second fraction and multiply, right?
Yeah.
What I'm going to do first is say, which parts do I need to restrict? Here, here, and here. I have stars by all the places I need to restrict. And now I'm going to continue. Flip the second and multiply. So times by 15y squared, still has a star by it. And then on bottom we have a 4x squared, right? Still has a star by it. Now before, in this one, I'm going to, before I actually start to before I start actually multiplying this straight across, I'm going to restrict first so that I don't miss where I'm supposed to restrict. So let's restrict right here.
Cannot equal 0.
Good. Y can't equal 0. Now restrict for that part.
Cannot equal 0.
Yep, y can't equal 0. Good. Now restrict for that part.
Can equal 0.
X can equal 0. And now we can continue. How do we multiply? We factor the top, factor the bottom. Factor the top, factor the bottom, done. We multiply straight across, don't we? Same steps. You have a 20 times 15. And then I have an x to the 5th. And then I have a y squared. That's all on top. And then on bottom I have a 3 and a 4. 3 times 4. Then it looks like I have a y. And it looks like I have an x squared. Do you agree?
Yeah.
We've already restricted, so we're good. And now we'll divide out exact factors. So look. 20 and 4.
5.
Good. 5 and 1. 15 and 3.
5 and 3. 1.
Yep, you're fine. X to the 5th and x squared.
X to the 3rd.
Yep, x to the 3rd on top, right? And then y squared and y would become y on top. So now what was left on top? 5?
5. X cubed y.
And then on bottom we had divided by 1, which is not necessary to write.
Ooh.
So then we would just circle our answer. Another one. Dividing fractions is easy as pie. We flip the second and multiply. So we're going to now have our 2x cubed minus 4x squared plus 8x on top. On bottom, we're going to have our x cubed plus 8. I'm going to make little stars where I need to restrict. Don't I restrict everywhere except for the top corner?
Yeah.
So I need to restrict here, here, and here. But to restrict, I need it factored. Otherwise, it's going to be hard. So let's first factor it. We'll restrict, then we'll multiply straight across. So let's factor it all. So tell me, everyone, let's all take a little part to make our lesson go quicker. You pick one of those and you factor it, and then you'll tell me which one you picked and what it factored to be. Ready, set, go. Everyone pick a different one.
Bottom right, x plus 2
Okay?
times x squared plus 2x plus 4. No. Oh, sorry. Minus 4.
Perfect. Okay, he did that one. Anyone else? Give me another one.
I gave the top left, and it's x minus 6, x plus 2.
X minus 6x plus 2. Anyone else do any of the others for me?
I have or top right.
Okay?
It's 2x, and then this is x squared minus 2x plus 4.
Okay, and then anyone have this one? Good. Pull out 2x squared, and then left would be 2x minus 3. Okay, now remember we got to restrict real quick, because if we multiply first and then restrict, we might forget which was the top corner, you know? Restrict right here. What would my restriction be? X cannot equal
0.
here?
No, wait. 2/3. 3/2.
Set it equal to 0. Add 3, divide by 2.
Yeah.
Okay, restrict there, right? Isn't that in that part?
Yeah.
So 0, we've already listed it. Restrict for that part.
It's gonna have eyes.
Okay, good. So no restrictions here.
-2.
And then here it has eyes. Okay, awesome. We've restricted. Now divide.
Take out the x squared.
2's divide out, don't they?
Yeah.
X and x squared divide out with an x, right?
Yeah. X squared minus 2x plus
And then you're saying those divide out?
4. Yeah.
So left on top was simply x minus 6. Left on bottom we had an x.
2x.
And then we had a 2x minus 3. Pretty easy, right, everyone? The only extra thing we have to remember is to restrict all. All 3. Okay, I'm not going to do any more. I'm just going to ask one question. On here, where would I restrict?
The bottom, and then the top and bottom. But you would flip that one and then multiply.
Good. We'd flip it and then we'd multiply. Okay, awesome. Awesome. Okay, that is the end of the lesson. So the rest of the time is yours to work on homework. I would go to 2-2 and start doing those. Every time you do the problem, I need you to say this. When we multiply fractions, we first factor all the parts, right? Second, multiply straight across, but don't actually multiply. And then third, we restrict. And fourth, we divide. You can't mix these steps up with the next lesson, which is next time. So every time, say the steps in your head. So you have them down so well, there's no possible way you could mess them up. I'm being